Okay, we're going to try another hyperbola. This is going to be one where the y squared is positive and the x squared is negative. So our forms will be flipped around a little bit. This will be our shape equation, and the y squared is in front. And this is our standard form, but it's y minus k squared, so the k is always with the y. That's the y coordinate of the center, and this is the x coordinate of the center. It's just that we flip these around because this is going to be the imaginary axis. The x-axis will be imaginary. The y-axis will be the real axis. So our vertices will be on the y-axis, or the vertical axis, I should say. So first of all, let's get this in our graphing or standard form or graphing friendly form. Excuse me. So first of all, I'll separate these out a little bit. So I'll say (18y), and then I'll put the x's together. Minus 16x squared, minus 64x, and I'll put the 99 on the right side, so it'll be positive 1999. Okay, then we'll factor the 9's out, so we have just a 1 in front of the y squared, so 9y squared minus 2y, leave room to complete the square, and take out a negative 16, and we'll have x squared plus 4x (9). And then we're going to remember our complete the square. What's half of 2? 1. What's 1 squared? 1. And x over here. And what's half of 4? 2. And 2 squared is 4. So remember now I'm adding 1 here, but it's preceded by a 9, so I'm adding 9, so I've got to add 9 to both sides. And here I'm putting a positive 4 here, but it's preceded by a negative, so it's negative 16 times 4, which is negative 64, so I'm actually subtracting 64 from both sides to balance that out. Now I can factor this out, so I've got 9. This is going to be y minus 1 squared minus 16 times x plus 2 squared. And that equals, and if I take 199 plus 9, I get 208 minus 64, I get 144. And usually these numbers will be nice enough, they'll work out fine. So I'll divide everything by 144 to make sure I have a 1 over here like I have in my standard form. And 9 goes into 144 16 times, so I've got y minus 1 squared over 16. 16 goes into 144 9 times, so I've got x plus 2 squared over 9, and that equals 1. So now I've got it in standard or graphing friendly form, so I can look at my center. So my center is going to be here at negative 2, because this is the x value, and 1. Okay, so that's my center, so when I go to graph it, that's what I've got. So I'll look over here, so my center is going to be negative 2, 1, negative 2, 1. So there's my center. I guess I should write over here that A is going to be 4 and B equals 3. And those are the distances I go from the center. Now my real axis will be the y-axis. Again, remember, we can always check that out, because if I just take the standard form, if I set x equal to 0, I have y values which are real, which is a plus or minus a actually. But here I would have plus or minus, or negative, plus or minus negative, the square root of b. So that, or the square root of negative b, which is going to be a complex number, but I still can use that to get my references for my rectangle that I'm using to draw this. So my real axis is going to be plus or minus 4. So I'm going to go up 4 and down 4 from my center. And then my complex or my imaginary axis is going to be 3, square root of 9. So I'm going to go 1, 2, 3. And those are going to be the points that allow me to get my good old rectangle. There's a point there, there's a corner point there, corner point there, corner point there, and a corner point there. And those are going to be my asymptotes. So I'll draw those. And here's the other asymptote. So that's what you got there. Okay, so those are your asymptotes. Now remember, my real axis is going to be on the y-axis, so these would be my vertices. So I could write my vertices down there. And that's going to be this point here, which would be negative 2, 1, 2, 3, 4, 5. And this would be negative 2, negative 3. So those are the points that actually touch the axes. And then you use your asymptotes here. And again, use a pencil so in case you have to kind of reshape it or erase it a little bit, make sure it gets closer and closer to the asymptotes. And I get a little bit off my graph here, so it's not really that great. But sometimes that happens, all right? Okay, so there's that upper branch, and you see this is the vertex, which kind of looks like the vertex of a parabola, so that's what I call the vertices. And then over here, this one goes like this. And there's your graph of your hyperbola. All right? And these are your vertices. Now if we want the foci, we can find the foci by using that good old formula, c squared equals a squared plus b squared. So you have to remember that. So a squared is 16 and b squared is 9, so that's just going to be 16 plus 9, so c squared equals 25. So c equals the square root of 25, which is just 5. So that's the distance from the center point that my foci will be, so it's going to be over here. And I'm going to go 1, 2, 3, 4, 5. And I'll go down 1, 2, 3, 4, 5. And those will be my foci. So I can find those coordinates now just by looking at the graph. So my foci. And they're going to still also have the same x coordinate, negative 2. And I can go up here, negative 2, 1, 2, 3, 4, 5. Oops. Oh, I'm sorry. I'm going with 5, so it's actually going to be 1, 2, 3, 4, 5. It's 6, right? Excuse me. And then I'm going to go down, so it's going to be down 5. 1, 2, 3, 4, 5, and that's going to be negative 4. So those are your foci. So from here I'm going to go, C is the distance from the center. I go up 1 on the real axis, which is going to be the vertical axis. 1, 2, 3, 4, 5, that's at 6, and down 1, 2, 3, 4, 5, and that's -4. Okay? So now we just have to find the equations of these two asymptotes. So this would be how we find our asymptotes. Okay. ASY M P T O T. So the asymptotes. So the equation of my asymptotes, if I look over here, if I look at my slope, I can just find my slope. I'm going to go up 1, 2, 3, 4 over 1, 2, 3. So M will equal plus or minus up 4 over 3. All right, or I could say I'm going from here, I'm going to go down 1, 2, 3, 4 over 3, or negative. So those are my slope. My point is going to be the point, the center point, because both the asymptotes go through the center point, which is going to be -2, 1. So I just have to find the equation of the two lines that go through those 2 points. I'm sorry, you go through the points and have that slope. So I need to find the equation of those 2 lines that have those 2 slopes that go through that point, excuse me. Okay, so we use our good old, so let's make sure you can all see this here. Y minus y1 equals m times x minus x1, our point slope form, which is very important. And y minus, this is my x1, y1. So y minus 1 equals 4/3 minus 2 is +2. So it's going to look like that, and the other one will be just the same thing except negative. So multiply this out. And 4/3 times 2 is 8/3. And then I'll just add 1 to both sides. But if I add 1, I'm going to add it to 3, so I'll just make it 3/3. That's the same thing as 1. Okay. So 8/3 plus 3/3 is 11/3. So that's why we want a common denominator. So 4/3 x plus 11 over 3. So that's one of our asymptotes. Now we need the other one where the slope is flipped. So I'll just say y minus 1 equals -4/3 times x plus 2. So everything's the same except for the sign here, because it's the other slope. And then we do the same thing. Y minus 1 equals -4/3 x, and that's going to be -8/3. Then I'm going to add 1 to both sides, so y equals -4/3 x minus 8/3, but only now plus 3/3, that's 1. Okay. Hope you can see that. Hope my writing isn't too ragged. You can always zoom in on these if you want. And then y equals -4/3 x, and then -8 plus 3 is -5. So that's your other asymptote. Okay? And there you go. So you have an asymptote here. This is the equation of one asymptote. This is the equation of the other asymptotes. And again, those are the lines that go through this point but have this slope. So we find the equation of the asymptotes. Okay? So there's a lot to these problems. They're really good to totally understand because there's a lot of good stuff, and we will apply these over and over as you progress on to more advanced classes. Hope that makes sense.